to What is the Best Method? Thank you for joining in today. We are excited. We have three new contestants. So let's meet our contestants. Mr. Tran, tell us about yourself.
Hi, my name is Lin Tran. I've been teaching for 7 years. I taught in Vegas for a year, moved to NorCal, taught in San Jose, and now I'm teaching at Los Altos. I'm teaching Geometry Honors and Algebra 2 right now, and I also coach badminton. So if you're at art school and you want to play, join us next year.
Okay, wonderful. Thank you. Mrs. Gantfarg, how are you doing?
Hello. Yes, my name is Andrea Gantfarg, and I grew up in Wheatland, California. And for the past 4 years, I've been teaching math at Los Altos High School, currently teaching algebra and trig honors, and I really love it. I have an amazing husband, Vlad, and an adorable, almost 2-year-old daughter, Adelaide.
Okay, wonderful. Well, I wonder if we'll see Adelaide during the show, because that would be a wonderful surprise. And our last contestant is Mr. Singh. Tell us about yourself, please.
Hi there. My name is Param Singh. I moved to United States 4 years ago. I've been teaching for 4 years. I live with my boyfriend in Los Altos area. I've been teaching at Los Altos the last 2 years. I taught algebra 2, trig, and statistics, and I absolutely love it.
Okay, thank you. Well, thank you so much for being here during our shelter-in-place version of What is the Best Method? So let's get started, okay? Let me tell you a little bit about the game. So we will have a special category today, and our category is solving quadratic equations. Whoa! I hope you're ready for this. So how this is going to go is I'm going to show a quadratic equation. You need to decide what method is the best method to solve. Now, we're not actually going to solve the equation, and I don't really care about what your solution is, but I'm more interested in what method you would use and why. So you have to justify. Okay, now contestants, we have decided that in order to buzz in, you are going to beep. Is that it? Beep. Shall we practice a beep right now?
Beep.
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 Okay, so then hopefully I will call on you. Now, if after the first person has beeped and shared their method, any other contestant can steal a point by saying maybe there's another method that would be better or more appropriate for that equation to solve. Okay, are we ready? Here we go. Question number 1, here's our equation.
Beep.
Mr. Singh?
Oh.
Was that Mr. Tran?
Yes, that was me.
Okay, you guys speak up, go.
Okay. I would solve this by isolating the variable, because there is an x squared there, so I know it's a quadratic, but I don't need to solve or use the quadratic formula because there's no x term. So when there's only one x term, I can isolate that. So I would take the 2 away and then square root both sides, and I would get the solution.
Okie dokie. Does any other contestant want to steal? Okay, we're gonna go on to our second question. Good job, Mr. Tran.
1 point for Mr. Tran.
Yeah, you keep track of your own score because I'm not gonna do that. Okay.
Beep.
Mrs. Gantfarg.
Okay, I think I would factor this one.
Really? Is it set up to factor?
So I would have to do something first, but I would subtract b to both sides, and then I would factor out a b.
Okay. Anyone want to argue for another method?
Nope.
Okay. Third equation.
Beep.
Mr. Singh.
Quadratic formula.
Why?
It has for example, x squared term, x term, and a constant. And then quadratic formula has the ability to, take in all those values as input, and it can produce 2 answers.
Okay.
Beep.
Does Mrs. Gamberg, are you going to try to steal this point from
I want to steal this. I think I would factor again.
Oh, do you just love factoring?
I do love factoring, but I noticed that there's a greatest common factor of 3 between all 3 terms. And so if I factor out the greatest common factor first, and then I would be left with r squared plus 7r plus 6. And I'm looking for 2 numbers that multiply to get to 6 and add to get to 7. And I can think of 6 and 1 as those 2 numbers. So I'd be able to factor it.
Okay, so it's factorable. So we can factor it and use the quadratic formula. Mr. Tran, do you want to try to steal? Is there any other method you can think of?
I think Ms. Gompart can only do that because she has amazing math abilities, mental math abilities. But if you were just anybody looking at this equation, you would say, I would try factoring because I wouldn't know it's factorable, right? Because you would avoid using the quadratic formulas because the numbers are big and it's going to give you a big mess when you do the quadratic formula. So I would try factoring, but I wouldn't know if it's factorable or not until I'm actually doing it.
Sure. Okay. Great justification. You can try factoring it, and then if it works, it works. If it doesn't, try another method.
Mm-hmm.
Okay. Good job. What? All 3 of you get points? Should I give you all 3 points?
Sounds good to me.
Sure. Okay. Problem number 4. Here's our next equation.
Oh, I'm sorry.
Mr. Tran.
Just looking at this, I would think factoring is not going to work, but I would try it first anyway. But the 11 in there tells me that this is going to be hard to factor. So I normally would go factoring first and then go into the quadratic formula. But I'm guessing this is going to be a quadratic formula type of question.
Okay.
But as someone who's new approaching the problem, I suggest trying factoring first anyway.
Is that it? Is that the best method? Anyone else?
Was Mr. Tran's final answer factoring or quadratic formula?
Oh.
I would say factoring.
Okay, then I want to try and steal that.
Yeah, Mrs. Gamberg, what would you say?
I think for the same reasons that Mr. Tran said that he would try factoring, I would say looking at those, I think the quadratic formula is going to be the best method for this one, even though the numbers are going to be kind of big.
Okay. I want you to notice that it's set equal to 10 though. Aren't all of your methods only possible if it's set equal to 0?
True. Yeah. We kind of we assumed that was a given, but yeah, that's right. We have to move the 10 over to make it equal to 0, subtracting 10 on both sides.
Okay, good. Ready for our next one?
Yeah.
Yay. Question number 5.
Beep.
Mrs. Gamfarg?
Factoring. I think factoring is the best method because it's set up for factoring where we can check to see all the factors of 8 and see if there's anything that we could add to get -9. And so we could quickly kind of go through that list and see if we can factor it.
Okay. So Ms. Gamfarg says factoring. Does anyone else say any other method?
Beep.
Mr. Singh.
Quadratic formula?
Why would you say that?
Would the factoring work?
Well, I mean, maybe Mrs.
Yes.
But would the quadratic formula also work?
Yes.
Yes, it would. So that's cool. Okay, we're gonna take a little pause. We're gonna say a little thank you to our sponsors.
We have sponsors?
We have, of course we do. Here's a little thank you to Zoom. Thank you, Zoom. You came out of nowhere. No one knew who you were until this time of vulnerability and digital reliance, and we thank you. This is only possible because of Zoom. And thank you to Rotting Bananas, because we can't eat you fast enough, and then we have to make banana bread. There we go. Thank you so much, Zoom, and Rotting bananas. Okay. Have we checked in? Have you guys kept track of your points?
Yeah, Mr. Tran has 5, Ms. Gangpark has 2, and Mr. Singh has 1.
I
More than 2.
don't trust Mr. Tran with that. I think,
I'm a math teacher.
okay. Sure. Okay, let's move on. Let's go back to the game. Here's question 6. There are only 10, so we're almost there. Number 6.
Hold on, I'm gonna get a partner.
Okay, oh, she's gonna start cheating now.
Okay,
Okay, well, that's not fair. She has help now.
I know, sorry.
4 contestants. Okay, here's number 6. What is the best method to solve the equation?
Beep.
Mrs. Gampark.
I think Mr. Singh beeped first.
Oh, Mr. Tran. I can't see.
Mr. Singh.
Yeah, it was Mr. Singh.
Okay.
Just start talking.
Difference of 2 squares?
What does that even mean?
What kind of method is that?
You guys don't know about difference of 2 squares?
Please tell me.
Okay, so there are 2 terms in here, 81x squared minus 4, so you can turn them both into like perfect squares. For example, 81 squared, 81x squared is 9x, and then parentheses, and then 2 outside, and then 4 is, 2 inside parentheses and 2 outside. And then you can equate that into the addition of 2 terms in parentheses and then subtraction of 2 terms in parentheses.
Okay. Well, that's a fancy method. Have we heard that method before? Seems kind of different.
I would,
can you comment?
Oh, I beeped, but that's cool.
Can someone talk?
Yeah, I can talk. I'll steal it from Mr. Tran. So I would try and isolate x squared and solve by taking a square root.
Ooh. Whoa. Mr. Tran, is there anything else that you could say?
I mean, you could do that if you want to stay basic, but I would factor that because I want to learn all the patterns in factoring. Because I want to get really good at factoring. And there are patterns in factoring where you want to know. So you don't want to stick with just isolating x all the time, although it does work.
But isn't that what Mr. Singh already said? Wasn't the difference of squares, isn't that factoring?
That's true, but I don't know difference of squares. So I would just factor how I normally would. And the middle term is not there, as you see. So I have to pretend that the middle term is a 0x. And I factor that way. And then it gives me what Mr. Singh said, the difference of squares.
Okay. Hey, I'm hearing some really great arguments. So you know what? All three of you get a point. Okay.
Nice. Up to 10 for Mr. Tran now.
And Mrs. Gamfarg has 100, right? Okay, next one. Number 7.
Beep.
Mrs. Gamfarg, was that your fancy beep going on in the
Yeah.
back? Okay.
So I would isolate the square in this one and take a square root. So I first divide by 5 to get the square by itself, and then take a square root.
Okay. Would anyone like to argue for another one and steal a point?
Can you square root both sides? What if the number is not nice?
Good question.
Yeah, can you expand on that, Miss Gangbar?
What do you mean by the number's not nice?
What if you have like 17 and then you have to square root that? That's not good.
I mean, 17 is not a nice number sometimes.
Well, can we leave a square root of 17 as just the square root of 17?
Is that even a number?
Yeah.
Oh.
Mr.
Singh, would you like to comment on anything?
No, I'm just enjoying this little chit chat. I think I agree with Ms. Gantvar. Because in this situation, I mean, if you look at the number, you have 125 on that side and 5 on that side. And 125 is perfectly, divisible by 5. So you'll have a nice number 25, and if you square root it, you'll get 5 on the other side.
So it actually is nice, Mr. Tran. It's not a nasty number like you're talking about. Square root of 17.
I have a question.
What's your question?
Wait, you divide by 5 and you don't square root both sides?
Yeah.
That makes no sense.
You gotta divide by 5 first so that we get the square part by itself. So that's what isolate the square root, or the square, so that we can take the square root.
Good point. Good thing I didn't beat myself in. I would have lost point on this one.
Exactly. Hey, last question before we move on. Is the quadratic formula possible in this equation?
Beep.
I don't know who said that.
Tran.
You're Tran.
It is possible if you multiply everything out and then put it into the quadratic formula. But I wouldn't do that because it's a lot of work.
Okay, but the point is, it's possible?
Yes.
Yes. Cool. So if you have all the time in the world and shelter in place, you could. Yeah. Okay, question 8.
Beep.
Mr. Singh.
I would isolate the variable on one side.
Okay.
And then get rid of the quantity that is in front of t squared, and then square root it, and then get the answer.
Alrighty. Is that the best method? Anyone like to argue for another one?
Nope.
Cool. Is the quadratic formula possible in this?
Yeah.
Only if you move the 6 over.
To be set equal to
0.
0.
Turn it into standard form first. Yeah.
Just turn it into standard form, but I noticed that there's only a t squared and a normal number without a variable, but there's no just t.
You can put a cute little 0 in front of t.
Cute little 0! Yay, good job. The audience loves that. Okay, let's go on to question number, number 9.
Beep.
Mr. Singh.
Yeah, same stuff. I'll get the variable. I will divide by 25 on both sides, and then square root it.
Okay. Is that the best method?
Another one.
Mr. Singh, you're going to steal it from yourself. Would you get 2?
Can I do that?
Oh, sure. There's no.
Okay, I'll give somebody else a chance.
Okay, I'll steal it then.
Okay.
So I want to use Mr. Singh's method from before. If we subtract the 49 to both sides, then we can factor it as a difference of squares. Because I know that 25x squared is a perfect square and 49 is a perfect square. And so if we're subtracting 2 perfect squares, it factors as a difference of squares.
Okay. Yeah? Mr. Tran, any comments?
Yeah, I know the best way though is not those. I would square root both sides first.
Whoa. But don't you have to divide by 25 on both sides?
No, you could square root both sides because the left side is just one single term. So you can just square root the whole thing. So you can square root 25x squared, and that gives you 5x equals to the square root of the other side, which would be plus or minus 7.
Mm.
And then from there, you can solve the 2 equations.
Okay. Now, here is our final question. Are you ready? Remember, this is about solving quadratic equations. In case you forgot. Okay, here we go.
Oh, man.
Think, 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 think. Think, 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 think.
Beep.
Mr. Singh? No, who was that?
Tran.
I can't hear you. Okay, Mr. Tran.
I would multiply the quantity out, the parentheses part. So I'll multiply that out because I'll take x minus 1. I'll multiply that out because I need to put everything into standard form before I can decide what to do. So I should have thought this through, but I'm gonna go through with this. I want to multiply it all out and then I can bring the 2x over because I see that there's an x squared and an x and a 2x on the other side. So I have two different terms of x's, one x squared and one x. So there's no way that I can isolate this. Even though the left side looks like you could isolate it by, you know, subtracting 3 and divided by 2, but can't do that because there's an x on the other side.
Mm-hmm.
So I'd have to get this into standard form. And then from there, I will have to decide what to do.
Okay. Any other contestants? Would you like to argue for or against whatever? Do you agree with Mr. Tran's method? Your
I agree.
silence?
A hard one to decide what to do. And I think that getting it in standard form first would be help us to make an easier decision.
Okay, good strategy, good strategy. Well, everyone, yay, that was a wonderful game. Thank you for playing along. Who won? Everyone, because we had fun, right? That's what you won, because okay. So that's what's the best method, shelter in place version. Stay posted for our next edition. Who knows what the category is going to be? Probably going to be something fun, just like this was, right?
Yeah.
Yeah. If you are interested in being a contestant on this game, follow me at Mathematician on Instagram, Facebook, or Twitter, and send me a message, okay? Thank you very much. Have a wonderful day. Bye. Everyone say bye.
Bye.
Bye.